Okay, so what I need everybody to do, take your triangles, okay? What is the blue triangle?
30, 36,
It's a 30, 60, 90. And your pink triangle?
45, 45.
45, 45, 90. What I need you to do is label each of them with hypotenuse 1. Who is in charge of blue?
Anthony.
Connor.
Connor.
Wow.
Okay, so the hypotenuse on each of these is 1. I would like you to use your special relationships. Let's start with the pink triangle, 45, 45, 90. The hypotenuse is 1. I need you to find the sides.
Got it.
Yes, I want you to write on your triangle.
So the hypotenuse is
The hypotenuse is 1. So 1 over radical 2 is technically correct, but I need you to write it. Label both sides, please.
This is radical 2.
Well, what do we know about the hypotenuse compared to the
It
label?
would be
Radical 2.
40 that we're working with.
no.
Yeah. Because it's 1, 1. And then
1, 1, radical 2. Okay. So if the labels are 1, the hypotenuse is radical 2. Right? Well, now,
I don't know. I did grad.
No,
listen, you need to write.
radical 2.
Yes.
Okay, I just want to understand it.
Right, so this is 1. Okay, so I see that we have 1 as our hypotenuse. Radical 2 over 2 is our legs. Make sure both sides of your triangle labeled. Then we're going to work with the blue triangle. If the hypotenuse is 1, please find me the legs. Do you next one?
No,
I'm just going to write it.
You do both sides. Both sides of both triangles need to be filled out. Yep. Okay, I'm going to ask you regular 1 and radical 3 over 2.
You have to opt in. So I know this question. Thanks, Phil.
I know.
Is this like
Say big or big? I can do that.
well, it's squared 3 times.
Every episode probably.
So if our hypotenuse is 1, what is our short leg? 1/2. And remember, our long leg is radical 3 times our short leg. So our long leg is radical 3 over 2. Radical 3 over 2. Please make sure both sides are labeled with the appropriate measurements. Both sides are labeled.
I record it on TV, so I can record it. I watched the whole thing on Netflix. Like a long time ago. Yeah, see the boys in Japan.
Well, spoiler.
He already knows.
Okay. So here's the deal. It is fine. Okay, if I asked you to evaluate a trig function of a special right triangle, you draw the triangle and then find me the ratio, right? Okay, and if it's in a different, if it's more than 90 degrees, you would draw the triangle, figure out which quadrant it is, and then give me the ratio. Okay? We are now in pre-calculus. We don't need to draw triangles every single time. If we have a special angle, 30, 45, 60, any multiples of those, even 90 degrees, we don't need to draw anything. What we're going to do is we're going to construct this unit circle, okay? This is something that you're going to remember. You're going to visualize this unit circle and be able to answer me trig questions about these angles. Okay? Yes. Okay, so this is what we're going to do first. Okay, we call this a unit circle. Well, here's the circle. Unit usually refers to what number?
1.
1. What is 1 about our circle?
One circle.
Radius. Okay, we have one circle. That's good too. We have one circle with radius 1. Okay, so this is where our origin is. Okay, if we have a radius of 1, here at 0 degrees, 0 radians, Anthony, what would our coordinate be?
1, 0.
We're at the coordinate 1, 0. Okay, because our radius is 1, we've moved right 1. Okay, here at 90 degrees, how many radians is that? Pi over 2. Okay. Noah, what would our coordinate be here? Okay. So we have a radius of 1. So if this is 0, 0, Noah, look up here. If this is 0, 0, and we move up 1 unit, what's our coordinate?
0, 1.
Yeah. Over here. How many degrees?
180.
Which is the same as pi radians. Seth, what's our coordinate?
-1.
-1, 0. Down here at 270 degrees, Travis, how many radians? 3 pi over 2. What's our coordinate? 0, -1. And then we can rotate back to 360 degrees, 2 pi. Okay? Those are the easy ones to remember. Here in a little bit, I'll tell you what all of these coordinates mean, but we're just going to find all of these coordinates for right now. Okay? So, pink triangles. Both sides are labeled. We have a hypotenuse of 1, and our sides are radical 2 over 2. Now, the hypotenuse is 1. Why would I make you label the hypotenuse as 1 for our unit circle? Okay, your hypotenuse is the radius. That's why I made you do that. Okay, so here at 45 degrees, our radian measurement is what, Justin? Pi over 4. Okay, all right, so let's talk about how we find x, y coordinates. X represents the which distance? Horizontal distance. We move horizontally to get to an x, and then we move vertically to get our y coordinate, right? So everyone, take your pink triangle. Match up your hypotenuse with your radius. Our sides are labeled, right? So how far do we move horizontally
Radical 2 over 2.
Oh, radical 2 over 2. And then from there we move vertically how far?
Radical 2 over 2.
Radical 2 over 2 to get to our coordinate, okay? Everyone look up here at my triangle. We move horizontally across the bottom of our triangle, vertically along the side of our triangle, so we move radical 2 over 2 to the right, and radical 2 over 2 up, and that's our coordinate. Make sense? Okay, let's take this triangle and let's put it in the second quadrant, okay? So if you see up here, we are 45 degrees away from 180. Where are we, Garrett? 135. You know how many readings that is? Okay, let's think about this. 45 degrees is pi over 4. We are pi over 4 away from pi.
3 pi over 4.
Okay, that's how I would remember it. We are pi over 4 away from pi. So 3/4 pi. Okay, so help me out here. We have a horizontal distance of what? Oh, why is it negative? Okay, we move to the left radical 2 over 2, so we have to label it as negative. And then we move up radical 2 over 2, so that will stay positive. So our x-coordinate is negative radical 2 over 2. Our y-coordinate is positive radical 2 over 2. Okay? Here in the third quadrant, we are 45 degrees past 180. Where are we? 225. Here in the third quadrant, we are pi over 4 past pi.
5 pi.
We are at 5 pi over 4. Okay. So, to get to our coordinate, we move horizontally to the left, radical 2 over 2. We move vertically down, radical 2 over 2. So, what's our coordinate? Man, it's like there's a pattern. All right, and then finally, in the fourth quadrant, here we are 45 degrees away from 360. That's 315 degrees, which is the same thing as being pi over 4 away from 2 pi. Cool, where are we? Excellent, 7 pi over 4. Okay. And looking at this triangle, to get to our coordinate, we move to the right, radical 2 over 2, and then down, radical 2 over 2. So, our coordinate is positive radical 2 over 2, negative radical 2 over 2. Okay, so let's take a moment, okay, before we get all of this filled in, okay? So all of these are 45 degrees away from the x-axis. All of these are pi over 4 away from the x-axis, okay? And they all have the same x and y coordinate, except the positive negative sign value changes, okay? We know from working with the coordinate plane since, what, 7th grade, 6th grade maybe? I don't even know when that begins. We know that in the first quadrant, x and y are positive. We know that in the second quadrant, x is negative, but y is positive. In the third quadrant, x and y are both negative. And in the fourth quadrant, x is positive, y is negative. Okay? Essentially, if you know what this coordinate is, you know all 4 of these coordinates, right?
Yep.
It's just a matter of keeping track of where the angles are. All right, let's grab your blue triangles, please. Okay. So we're going to do 30-degree angles, all right? So 30-degree angle, Sarah Kate, how many radians is that, do you know? Hannah, help around. Pi over 6. Okay? By tomorrow, we all will remember that. Okay? So let's put our blue triangle up here so that our hypotenuse matches up with our radius. How far do we travel horizontally to get to our coordinate?
Radical 3 over 2.
Radical 3 over 2. And how far do we travel vertically?
1 over 2.
1/2. Use your triangles with me so you can visualize it with yours. Okay, over here in the second quadrant, we are 30 degrees away from 180.
Over 6.
Do 150 degrees, right? We are pi over 6 away from pi. So, Alex, what would that be? Boyfriend. 5 pi over 6. Right, or a sixth away from 1. And throw the pi back in there. Okay. All right, let's talk about this coordinate. We move to the left, radical 3 over 2, and then up 1/2. So negative radical 3 over 2, 1/2. Is there going to be a similar pattern here? Okay. In the third quadrant, 30 degrees past 180. 210. We can also think of this as pi over 6 past pi.
7.
I like this. So it's 1 plus a 6. Or I think in pepper cracker. There you go. 7 pi over 6. Okay? To get to this coordinate, we move to the left, radical 3 over 2, and then down 1/2. So negative radical 3 over 2, negative 1/2. And in the fourth quadrant, we are 30 degrees away from 360, which would put us where? 330. We are pi over 6 away from being at 2 pi, so Austin.
Pi over 6.
Excellent. Garrett, what's our coordinate?
Radical 3 over 2.
Radical 3 over 2, negative 1/2. Okay? So all of these angles, look at them. They're all 30 degrees away from the x-axis, or pi over 6 away from the x-axis. They all have the same x and y coordinate, it's just the positive and negative change. Okay? Kind of looks like a butterfly, right? That's not what a butterfly is. But good try. Okay. Last but not least, 60 degrees. 60 degrees is how many radians, Stephanie?
Wow, pi over 3.
Pi over 3. If we put our triangle up here so that our radius is the same as our hypotenuse, we move horizontally how far? 1/2. And vertically, radical 3 over 2. So our coordinate is 1/2 radical 3 over 2. Okay. In the second quadrant, we're 60 degrees away from 180. How many degrees?
120 degrees.
120 degrees. We are pi over 3 away from 1 pi. Bailey, how many radians? We are pi over 3 away from pi. Very good. 2 pi over 3. And to get to our coordinate, we move to the left 1/2 and up. Radical 3 over 2. In the third quadrant, we are 60 degrees past 180. Mason, what would that value be?
240.
240. Same as being pi over 3 past pi. Okay.
4 pi over 3.
Very good. Our coordinate, we move to the left 1/2 and then down. Radical 3 over 2. And our last coordinate. We are 60 degrees away from 360. Connor?
60 degrees away from 360. 300 degrees.
Pi over 3 away from 2 pi. Split. What's our radian measure? Good. Everybody together. You probably already filled it in. What is
2
our
over
coordinate?
4. Like 2 over 4.
1/2 negative radical 3 over 2. Okay. Yes, it's beautiful, isn't it? Here's our unit circle, okay? So, a couple things I want to point out, okay? What do you notice about the 30-degree coordinate and the 60-degree coordinate? They're flip-flopped. Okay, we use the same triangle to come up with those numbers. Okay, so if you know the 30-degree coordinate, well then you know the 60-degree coordinate. It's just that. Okay? And the 45-degree coordinate. Okay, X and Y are the same. So that's a pretty easy coordinate to remember. There's really 3 numbers in that first quadrant you have to remember for those coordinates. 1/2, radical 3 over 2, and radical 2 over 2. It's just a matter of where each of them are. Okay? Now I want you to notice the symmetry. Okay, like I said, it looks like a butterfly. Okay? So anything that deals with 60 degrees, the radian has a 3 in the denominator. And they all have the same coordinate, the positives and negatives just switch. Okay? Same thing for each of the other ones. 45-degree angles all have a radian, something over 4. And they all have the coordinate radical 2 over 2, radical 2 over 2. We just throw some negatives and positives in different places, depending on which quadrant that we're in. Okay? Now, why are we taking so much time to create this unit circle? And why am I going to have you memorize the unit circle?
So, these are the triangles.
Okay, let's talk about what we used to do. If I asked you for the cosine of 30 degrees, you would draw a triangle, and you would label this as 1, 2, radical 3, and you would tell me that the cosine of 30 degrees is what? Radical 3 over 2. And then I would say, all right, well, what's the sine of 30 degrees? You would look at that triangle, and you would tell me 1 over 2. Instead of drawing a triangle, we can look at coordinates. I want you to look at this 30-degree coordinate. Radical 3 over 2. That was the cosine of 30 degrees. 1/2.
Sine.
That was the sine of 30 degrees. So instead of drawing all these triangles, what we can remember is that each xy coordinate represents the cosine and sine of each angle. Okay. And then that way we can visualize the unit circle and say, all right, I know what the sine of 135 degrees is. What is the sine of 135 degrees? Kylie. Radical 2 over 2. We know that because that is the y-coordinate at 135 degrees. What is the cosine of 3 3 pi over 2. Isaac.
Oh, it'd just be,
It'd be 0 because the x coordinate at 3 pi over 2 is 0. Okay. Let's see. The sine of 11 pi over 6. Ryan, how do we find it? Negative 1/2. Because at 11 pi over 6, the y coordinate is negative 1/2. Okay? Now, you're not going to draw the unit circle every time. Okay? The purpose of this is to remember it and visualize it in our heads. Okay? Now, what if I wanted to find the tangent of an angle?
Y.
Very good. If you want to evaluate tangent, the tangent of theta is y over x. So let's look at that. Let's talk about the tangent of 45 degrees. Okay, so our coordinate at 45 degrees, our y coordinates radical 2 over 2, our x coordinates radical 2 over 2. So the tangent of 45 degrees is 1. Okay? Those 45 degree angles. It's going to be nice when we have to evaluate tangent, don't you think? Let's talk about the tangent of 90. I was going to wait to do this, but you brought it up. Tangent of 90, what would our ratio be?
1 over 0.
1 over 0.
That's not my.
We can't divide by 0.
It makes a black hole.
So we say it's undefined. Chuck Norris can't even divide by 0.
Oh, I think.
I don't think so.
It makes a black hole. Steve Mans did that by line.
Now, I will remind you, I believe your Algebra 2 teachers taught you this last year. But what I want you to notice is that everybody is positive in the first quadrant, correct? All of us are positive, okay? The x's are negative in the second quadrant, but the y's are positive, which means if we try to go find tangent, y over x will also be negative. So who's the only positive one out of the 3 here? The y coordinate represents sine. Now in the third quadrant, x and y are both negative, which means sine and cosine are both negative. So what would that mean about tangents? The tangents would be positive. And then in the fourth quadrant, our x values are positive, which stands for cosine. You may remember your teacher telling you, all students take calculus. It's motivational. Okay. But that can help you remember who's positive, who's negative. Okay? As you're picturing the unit circle, once you have it memorized in your head, okay, as long as we know the first quadrant, we know all of the other ones. Because if you know these 3, everything repeats. Okay? It's just a negative section.
I remember the whole acronym thing I did, like, but I forget like what exactly they mean. Can you just another time?
In the first quadrant, we're all positive. In the second quadrant, only sine is positive.
Okay.
Tangent, cosine. Now, let's talk about how we would work with the other functions. Okay, so we've talked about sine, cosine, tangent. What if I asked you for the cosecant of 5 pi over 6? The cosecant is what?
2 over 1.
Okay, so I'll get to you. The cosecant is the reciprocal of sine. Well, the sine at 5 pi over 6 is 1/2, so our reciprocal is 2 over 1. Okay. The secant of 7 pi over 4. Okay, the secant is the reciprocal of cosine. Well, the cosine at 7 pi over 4 is radical 2 over 2.
2 radical 2 over 2.
Yeah. So this is how you would flip it, right? But this is not rationalized. When we rationalize it, we get just radical 2. Because 2 radical 2 over 2, those cancel, right? Once you rationalize it once, I'm hoping that you remember how to rationalize it again. Cotangent, how would we find a cotangent? Okay, so x over y. Okay, so I'm going to give you 4 problems here. Oh, no, okay.
Oh my Gundersons.
Just like orange and.
Okay, so do these 4 and compare your answers as we go.
So you want the position?
I want the ratio.